Hi, I'm Lynn Langett. Welcome to Scaling Galaxy on Google Cloud Platform. In this presentation, I'm going to talk about scaling the Bioinformatics tool Galaxy on GCP in two ways. One, by scaling up, understanding how to use virtual machines hosted on Google Cloud by getting Galaxy working, hello Galaxy, adding tools to it, and then talking about the genomic data that's available on the Google Cloud. The second aspect will be scaling out. Here I'm going to look at some newer technologies in virtualization, notably containers. I'm going to be working with Kubernetes on GCP and getting Galaxy up and going there. Then I'm going to look at Google Persistent Disks for storing your work. And finally, I'm going to close by looking at the future, which is pipelining, and that's stringing Google Cloud services together, such as the Google Cloud Genomics API and BigQuery, to scale your bioinformatics pipeline in a very massive way. The reason for talking about this is that I'm here in Australia and the Google Cloud is going to open a data center here in 2017. So it's going to provide you with more choice in terms of your public cloud providers. So let's take a look at scaling up. For the first demo, I'm going to use a series of scripts to set up two instances of Galaxy on the Google Cloud. The first one will be running the plain vanilla version of Galaxy, and the second one will be running a version with the startup script, which will install some additional Galaxy tools. There are a couple of prerequisites. You would need to have a project, so you could create a project, and then you would need to enable the services, which you do under the APIs. To enable the APIs, you go to the API Manager, you find the APIs, you click Enable API, and you're going to want to enable Google Cloud Compute Engine for virtual machines. For a subsequent demo, if you're interested in containers, you'll want Google Cloud Container Engine, and you simply click the API, and then up at the top you click Enable. They're not enabled by default. Now, to get this running, I'm going to go ahead and go over to Compute Engine and show that we don't have any virtual machines right now. Now, although you could click through the console to do this, a better practice is to use scripts. There is a tool called gcloud that we're going to use. What I've done in advance is I've downloaded the gcloud tool. I have run gcloud auth login to associate my email with this project name to get started. So I've done all that in advance. So in addition to that, all my scripts are publicly available in this GitHub repository, and we're in the Galaxy section. And inside the Galaxy section, we're going to start with the setup VMs. And I have instructions on how to get started that we're going to be following here. Now, the very first thing is we want to take your project name and your email, and we want to update that in the CLI RC file. And that file is right here. So when you pull that down, you're going to want to take these two values and you're going to want to update them with your values. And then to stand up two instances, you're just going to go to the bash shell and run this script, which I'll show you now. So you want to navigate to the directory where you've downloaded this, and then you can see your files. And you want to make sure that you've updated this information by catting it. And you can see I've replaced the information with my project information. Now, inside of here, you're going to want to run the bash shell, and then you're going to want to run the first script. You can press tab to complete. Now, while this is running, I'll show you the things that are occurring. We're creating a firewall rule to allow us to connect to our Galaxy instances. We're creating a client image based off of a source file out of the Galaxy repository, and then from that image, we're creating two instances of Galaxy. On one of the instances, it's a plain vanilla setup, and on the other instance, we've demonstrated showing a startup script that will install additional Galaxy tools. The idea with this is to fully script the setup and takedown of your Galaxy instance with your tools so that when you're collaborating with your colleagues, you can share configuration by just standing up and pulling down instances rather than creating images. It's a faster way to work with the Google Cloud. So this will take a couple of minutes, and while this is running, I'm going to go back and review the script with you. You can see first we're using that variable, then we're logging in. Then we're creating a firewall rule. Then we're creating an image, and you can see there's our source file on line 19. Once that image is available, then we're creating two instances. And you'll notice the first one is a plain vanilla instance, and the second one calls a boot script. The boot script retrieves a script file from Galaxy to install additional tools. It then restarts Galaxy to make those tools available. Let's check on the progress. If we go over to images, we can see our image is spinning up. Now this takes a couple of minutes, so I'm going to pause the video and then come back when it's completed. We can see that our image has been created and now the instances are running. Let's look what that looks like in the console. If we refresh, there's our image. Also, we've set in networking a firewall rule to allow HTTP traffic, which is the default for Galaxy. Now we're going to go to Compute Engine, and you can see that our instances are spinning up. Now, according to our script, our instances are ready. So let's return to the console and verify that. And let's go ahead and copy the external IP address. And my credentials have been cached. The login is admin because of previous tries. And you can see that the default instance of Galaxy is working. Now, what I could do is I could SSH into this instance. Note that in the Google Cloud, unlike other cloud providers, there's no need to download and create keys. Google handles that automatically and securely connects you via SSH client. Now inside of here, I can run a Linux command, and then I can install tools and work with Galaxy this way if I wanted to. However, in addition to this, as I mentioned earlier, on the second instance, we've run the startup script, which installs the tools. So let's make sure that they're working. In this one, we have to log in because it's not cached. And you can see that we've imported the tools. Now, a great thing about working with scripts is that in combination with the speed and flexibility of the Google Cloud, you can easily stand up and stand down instances very, very quickly. So in addition to spinning these up, what we can now do is we can run a script to tear everything down, and I'll demonstrate what that's like next. So in running our cleanup script, it's going to remove the firewall rule, it's going to delete the image, and delete the instances. And the script is completed, so let's validate on the console. And if we refresh, our instances are gone, our image is gone, and our firewall rule is gone. Let's recap what we've learned. We used Google Cloud Platform Virtual Machine Services. We were using the file storage, which are called buckets, as source data for our image. We were using Compute Engine virtual machines, and we were creating image files out of source data. A key concept at this point is rather than always making a complete image of a machine, the boot disk and the persistent disks, in the world of Google Cloud, it can be cheaper and easier to simply do scripts and spin up instances and spin them down. So patterns around scale up for GCP are that you can resize your virtual machines. You can notice here that in the machine type, you can just drag the sliders for cores and memory to set whatever type you like. This is a particular advantage of Google Cloud as compared to some of the competition. And notice to the right, it tells you how much that's going to cost you. You can attach a number of persistent disks. The number and amount depends on whether they're SSDs, regular hard disks, and the amount of CPU and memory that you have. I have details for those of you that are interested, but it can be very many, up to 16 persistent disks for most of the machine configurations. You can update your base image pretty easily. So if you want to change your Galaxy base image and install tools on your base image, you could do that as well. And there's a new set of tools called StackDriver. It's a company Google bought that helps you with sizing. So there are different levels of access to StackDriver. You can try it out for free. It is a premium service, though you have to pay for it. But again, it can help you to right size for your particular workloads. So it can help you to utilize the VMs more efficiently. Now, the next aspect of working with Google Cloud is they are very committed to providing public genomic data on the cloud so that you don't have to download it, so you can just work with it either with VMs or other services. And I just wanted to reference for all of you where you find that. It's on GS, which is their cloud storage bucket address, genomics-public-data. You can query this data out of a BigQuery service that we'll be talking about a little bit later in the presentation, and you can code against it with Genomics API, which is another service. Now there is also a browser for this, and I did include a screenshot here of the browser. So this is an application that you can use to browse data that's set up as a data set on the Google Cloud. So the next pattern to look at is scale out. Now let's look at scaling out. The pattern here is around Docker or container services. It's called GKE on Google Cloud. So the idea is you'd use cloud storage, so files, but rather than using compute, Google Compute Engine or VMs, you'd use containers. Now Galaxy has already been containerized, and so I have a simple proof of concept demo just to show how it runs on the Google Cloud container services, because it's not only containers, it's also container manager, which in Google Cloud is something called Kubernetes. The idea here is rather than having configuration around your VM, you have configuration around your containers to spin them up, spin them down, and scale them. And why you may be interested in this is if you have very, very large workloads, it can be cheaper because you're more effectively utilizing the resources of the underlying VMs by putting n number of containers on them. So this is a quick snapshot of the Kubernetes dashboard, and this is akin to the idea of Stackdriver monitoring the VMs. The idea here is that you can put multiple containers, or pods they're called in this vernacular, on an underlying VM, so you can get more effective use depending on the type of workload that you're running. So the pattern here is that you use the Docker container cluster, use the Kubernetes manager, and you're doing what's called container orchestration. As I did in the previous example, I've created a set of script files that you can use to just execute this, which I'll be showing you in a minute. Of course, you could just click in the console, but I think that this is more easily accomplished by using these script files. So to do this, let's go in the Galaxy subdirectory of my repository, and then I'm going to go into Setup Kubernetes, and I'm going to go into the Kubernetes steps. As we did in the previous section, there's a resource file. You need to add your particular project name. Once you do that, and you've got gcloud set up and you've authenticated in, then in a command window, you're going to run the startup script. Let me go ahead and open a command window and show you that I'm in the correct directory. And then inside of here, what I want to do is run this stand-up file. And let me show you what it's doing. So this is importing the configuration. It's setting the CLI defaults. And then it is using the container command, and it's creating a cluster. It's creating compute disks of size 500 gigs each. Once it's set up, then we are getting the credentials. Now, after the cluster is up, we can deploy Galaxy with the Kubernetes control command, and then we'll be applying a YAML or a configuration file. So let's take a look at that YAML file. So inside the YAML file, you can see that we're getting the image from Docker and we're mapping ports. Then inside of here, we're also creating a service so that we can interact with this Galaxy instance through port 80. So let's copy this command. Now we could speed up the creation of this by using formatted disks. And while we're waiting, let's take a look in the console. And you can see the container cluster is being created at the size of 3. Okay, our cluster should be complete, but let's validate that. It's ready. So now we're going to associate Galaxy with one of the instances. Now we're going to monitor the progress of the deployment by creating a proxy that we can connect to the Kubernetes UI. And now we're going to take a look at the cluster. Now sometimes this takes up to 5 minutes. We might have a failure when we first look at it. Let's refresh to check the progress. This is expected. Sometimes this takes up to 5 minutes. And let's refresh again. And now it's ready. So if we want to access Galaxy, we go to Services and Galaxy. And here you see Galaxy running on a Kubernetes cluster. And to verify that, let's look over here. And you can see there is our container cluster. And if we go back, the underlying resources in this case are 3 VMs. Now we're only running a single instance just as a proof of concept. And there's a lot of work to be done in terms of scaling out. And this is something I'm really interested in talking to the Galaxy community about. Now, as we did with other services, we can script to remove everything. So let's do that. We have a teardown script that simply removes everything. We do a Control-C to stop the process, and then we run the teardown script. Let's check the progress in the console. Cluster has been removed and the VM instances are removed. Now a really new area is this idea of serverless, and Google does have an offering coming here. As of the time of this recording, this capability is in alpha. It's called Google Cloud Functions. It's microservices. The idea is that the compute functionality is abstracted even higher level than Docker. You literally write a method or a function, and then Google sets up all of the other infrastructure, including the containers, container management, and underlying VMs. The idea is that you have a function which is configurable as code. It's fast, cheap microservices. Now, building on the idea of functions scaling, we move to advanced pipelines. Google has been doing some work around a Genomics API, which does variant processing. Now, this is very early work. It's in the alpha stage, and one of the reasons I've come to this conference is to be a conduit of feedback from the bioinformatics community back to Google. And because I don't work for either, I can be very unbiased, so I really want the honest opinion. Be aware if you try this service out as an alpha service, it's not designed for production, and Google's really just trying to understand what the community needs in terms of serverless and domain-specific functions. You can see the idea here is that you have your information coming in from sequencing, goes into Google Cloud Storage, and then Genomics is your scalable serverless API, your first level of processing. They have also provided a set of cookbooks that I'll reference in the end of this presentation that show you how to do subsequent processing once your variant results are output from the Google Genomics API via other services such as BigQuery, which is a SQL style service that allows you to do SQL queries against defined data sets in BigQuery, and very elegant way of scaling a large pipeline. In this example, we're going to use BigQuery to analyze variants. So we're going to work with the Illumina Platinum genomes and compute the ratio of transitions versus transversions in SNPs in each 100,000 base pair window. You could use your own variants, but we're going to go ahead and use the data that's already available for BigQuery to work with. To access BigQuery from your project, click on the menu, scroll down, click on BigQuery, click on Compose Query, paste the query that we just worked with, click on Format Query. Let's go ahead and run this query. You can see that in 7 seconds, we processed 11 gigabytes of data. Truly query as a service. Google has published patterns around how they are designing their services to support bioinformatics pipelines. Again, I'm very interested in providing information back to Google about what will interest you and what will work for you. The concept is scaling via services rather than machines. And so the idea, for example, in this particular reference architecture is that you would get your sequenced results and you would use the Genomics API to do the first level of variant analysis. You would utilize the public genomic datasets hosted on the Google Cloud as part of your pipeline as you were processing your variants from your particular samples coming in. Now there's another product called Cloud Data Flow that is a very scalable set of workflow processes for data that goes really beyond the scope of what I'm talking about. But if you have high scale pipelines, particularly commercial, and I'm thinking that most of you are not needing that much volume because you're doing research, but it's coming to the case where research is having that much volume, that's another product you could look at in terms of scaling processes. In addition, in this workflow, Google shows using BigQuery along with another service called Cloud Data Lab, which is Jupyter-style notebook, which I see now that is also enabled for Galaxy. The idea is that the components of the pipeline are plug and play, and they scale via various methods, whether VMs or containers or functional services. Now, an even more complex architecture is around commercial genomics analysis pipeline, and this is designed for very, very high scale. So the idea is you have multiple results coming in, goes to a cloud network, so you have fast connectivity, and then you have load balancer going to several compute engine servers that are running various processes. You can even run an HPC cluster, and again in the Genomics Cookbook there's patterns for how to set this up, and then multiple types of storage using either BigQuery or some other process to do analytics, and then presenting the output for the scientists in Cloud Data Lab notebooks. So the core products are in these pipelines are cloud storage, public data sets on GCP, BigQuery, Cloud Data Flow for very high volume, and Genomics API as it moves from an early status, an alpha at this time of this recording, into more of a production level API. The key concept around this is that pipeline configuration is now your code. So if you had a dev environment moving to a prod, for example, like I said, more of a commercial type of an implementation, then you would have fast, cheap, scalable cloud services. So for resources, this is the cookbook that I've been talking about. I've used it for skilling up on learning more about your world, and it's been useful to me. I would also be interested in providing Google with feedback on how and whether this is useful to you. Here is an additional set of resources around the particular services. I reference quick starts. And with that, I want to thank you for your time and attention. I hope you found this useful. I really want to share with the community from a tech point how we can best utilize cloud resources to make the work more efficient, more effective, and even more fun. Have a great day.